So in this video I'm going to show the practical implication of the KVL. That is how to use practically the KVL. Means to verify our theoretical calculation with the practical calculation. So for that I have brought this circuit. So you can see this circuit is made randomly, and this is the software which I am using is the Proteus. I have made many videos on, I guess 3-4 videos I have made on the Proteus. So if you want I can make the video on how to use the Proteus. It's a very simple. I guess that's no need of making video also. In some video I guess I have told how to use Proteus in the starting. So that's okay. We will move ahead with what the concept we are brought. No, don't get distracted in anything else. So I have took the voltage sources and resistance. I have made one circuit. If you want, make the same circuit in your paper. Okay. So let's start putting the KVL to this circuit. So first we will assume the current direction. Always in the K before putting the KVL to the loops, first assume the current direction. You can assume any direction, whatever you want, however you want, you can assume. If your current direction is current, at the end you are going to get the values in the positive. If your current direction is wrong, you are going to get the negative. So you have to choose the current direction in the opposite. It means the current direction of your choose is wrong. That's what the meaning is, direction of current. So one more thing, in the previous video I forgot to tell why the KVL is. KVL is mainly is used to find the current values. You can, by using KVL you can find anywhere any loops current. Means you can get the current values what in that loop is going on. Okay, that's what the KVL importance is, and it's a very important law. But most important law is Ohm's law, because KVL cannot be derived without using a Ohm's law. So in the previous videos I guess I have made on the Ohm's law. So that's very important law. Next is KVL. So now let's put the KVL to this first loop. First I will assume the current direction of this loop has, from this node we will consider the current is going to go from in this direction, 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 and coming back to this node. And in this loop we are going to assume the current direction as in this direction, 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 this direction, this direction, this direction, this direction. So we have assumed the current direction. You can assume the current direction opposite what I have assumed. You can assume the current direction in this way, and you can assume this loop's current direction in this way. That's also okay. I assume the whatever the directions I have assumed, that is going to make the easy while taking the value at this place. We are going to get the positive values of current in this place if you assume the direction what I have took. You can assume the current direction opposite of each other also. That's also okay. If you check, the values are going to come same. Might be the sign is going to be different, because if your assumption is current, the sign is going to be positive. If your assumption is wrong, it is going to be a negative. That's what the assumption of current. Now we have assumed. Now let's put the KVL to this loop first. I will go from here, here, here. Now let's go from here and come back to here. So if I go from here, first we are going from minus to plus. It is going to be plus 1. This I have made in the previous video how to apply KVL to a loop. Then I'm going to go like this, like this, like this, like this. So 1. So it is a resistor. So it is going to be a drop. We will take it as a minus. So minus, it is minus R1 into I1. Then we will go in this direction, 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 in this direction. So here we have came. In this resistor there are two current are going. The loop current of this and this loop current also. So we are going to take it as I1 plus I2 into R5. Okay. Then we will go in this direction, this direction, this direction, this direction. Then it is going to be minus R3 into I1. So our whole equation is going to be 1 minus 2 into R1 minus 1 into I1 plus I2, then minus 1 into R3. This is the loop equation for this. By simplifying that, we are going to get it as 4i1 plus i2 equal to 1. This is a simplified version of this loop equation. In the same way, we will apply for this loop also. We will start it from here, then we will go here plus 1, then minus r2 into i2, then here if we come minus 1 into i1 plus i2, then we will go here, then we will go here, then we will go here, then we will come here, then it is going to be minus i2 into r, and we will end at the same node wherever we have started. So by simplifying this equation, we are going to get it around 3i2 plus i1. That's what the second loop equation. Now by using calculator or by solving the simple mathematics, we are going to get the value of i1 and i2. So I have solved it and we have got the value of i1 and i2 has 0.1818 i1 value and 0.2727 i2 value. These are the values what we will get. So we have got both the positive values, means both the loop current's direction whatever we have assumed is correct. So that's what the meaning we will get. Our assumption is correct. If I would have got the minus, then our assumption was wrong. Okay. Now I will run it. I have put the probes here to see what values we are going to get. So as you can see, our theoretical value and practical value both are correct. That is 0.188, 0.181818 and 0.272727. Okay. And it's a positive, and why it is a negative might be seen, because the probe's direction is showing is being chosen in this way. So that is why it is coming minus. Actual direction is this, but according to this arrow it is this, so it is shown as a minus. Okay. So if you see what is the current flowing, this resistance is going to be, it is going to be 0.18 plus 0.27. That's what is the value. So that also I can show. Let me see if I can show. Let's try. I guess some error might come. We can't use probe, I guess. Here we will use an digital ammeter. We'll go in the virtual instrumentation mode. This last option you have to go if you want any digital voltmeter and ammeter. Here it is an ammeter. Let me take this ammeter. I will place it here. I will connect it between. Ammeter is always connected in series wherever you want to see the value. Okay, it's showing. So let us add the 0.45 is the value it is coming. Let us add the 0.1818 plus 0.2727. So yes, 0.45 is the value I am also getting. So that means the current direction was correct, and whatever the theoretical values we have calculated, that was also correct. So to get more hand on to the KVL, you can make some other loops and work on it. This is a very good software. You can use it to see whether you are getting whatever value is correct or wrong. Other than using the chat GPTs or and all, you use such softwares to understand very well the concepts. So that's it for today. Thank you.